So, greetings of the day. I am Sakari Mathuri from Center for Nanoscience and Technology from JNTU, Hyderabad. And today's presentation goes with the title Sketchy Synthesis of Mn3O4, Mn3O4 with activated carbon, and Mn3O4 with carbon nanotube composites for the application in energy caching. And the abstract goes with like this. So with different energy concerns and the that causing environmental issues and the depletion of the fossil fuels, the generation of the renewable resources, wind, solar, thermal, and hydropower, plays a great role in the development of the human society. To empower these structure evolutions, trusty energy systems such as fuel cells, batteries, supercapacitors play an important role for the energy development. So, current enlargement in the ground of wearable and transferable devices augmented their reputation throughout the world. So, many efforts have been devoted to increase the capacitance of supercapacitors by adding conductive additives such as carbon composites or carbon electrodes. So, the cycling lifespan and charge discharge property of supercapacitor makes it suitable for the energy density application. So, the constantly changing technology with supercapacitors are lowering the cost. So, these supercapacitors involve two non-reactive porous plates, such as two electrodes, anode and cathode, which contains the electrolyte, and two current collectors through which voltage is applied. So the surface area plays a vital role in the supercapacitor applications. This can be improved by incorporating carbon electrodes. So in this method, we have employed a sol-gel method for the synthesis of these composites. These composites were further characterized using XRD, FSM, FTIR, cyclic voltammetry, charge discharge analysis, impedance spectroscopy, and these are the techniques that were used in this work. And the experimental procedure goes like this. Manganese acetate and citric acid with 1 is to 2 ratio were taken in and stirred for half an hour, and simultaneously carbon nanotubes and activated carbon separately were dissolved in 30 ml of distilled water and sonicated for half an hour, and these two composites were mixed, and pH was maintained 7 by adding ammonia drop by drop, and this was stirred for 2 to 4 hours until the gel was appeared, and this gel was collected and dried at 100 degrees centigrade and calcined at 400 degrees for 4 hours to remove the impurities. So while coming to the characterization techniques, uh, the first one is Fourier transform infrared spectroscopy, and these were confirmed with the bands in the literature. In the bending at 650 is attributed to MNO and 1384 to OH group, and 1631 and 3453 to OH, and the CC stretching which was attributed to the CNTs and activated carbons at 2920. In the XRD analysis was confirmed with the JCPDS card numbers, and the size for the 1 is to 2 ratio of manganese acetate and citric acid is 20.81 nanometers, and for the ratio of 1 is to 4 was 18.9. In the cyclic voltammetry analysis of these composites, Mn3O4, Mn3O4 activated carbon, Mn3O4 carbon nanotubes were studied, and the specific capacitance observed at 10 standard was uh, 23.8, 28.8, 49.79, and while at 20 standard it was observed 12.36, 21.6, and 29.9. Well, coming to charge discharge analysis, uh, this was studied for different current densities, and the last one was studied at 1 ampere per gram current density of these three composites, and the specific capacitance observed for using charge discharge analysis was 71.6 for composite with the carbon nanotubes and 13.12 for activated carbon. And while a single Mn3O4 composite was 8.91. While coming to electrostatic impedance spectroscopy, the vertical line with certain slope indicates the low diffusion resistance, indicating that less amount of charge transfer resistance. While coming to SEM and IRAX analysis, the IRAC spectrum was related to constant composition analysis, and comprising this indicates comprising with three elements such as manganese, oxygen, and carbon. Carbon was with traces of the precursor material. Hence, it is proving that the formation of pure Mn3O4 crystalline material without any impurities. So the composites were analyzed with having three elements: manganese, oxygen, and carbon. So these are the conclusions in which a simple, cozy, cost-effective method Sol-gel was employed for the synthesis of these materials, and XRD was used for the confirmation in the structure and as well as size analysis, and FESM for the morphological studies, FDR for functional group analysis, and electrochemical measurements for determining the specific capacitance of the three active materials. And these are the references, and I thank the Kitty for the funding and my guide for the constant support. And this is the contact information through which you can contact me at any time. Thank you. Thank you so much.